Good morning, everyone. My name is Juan Carlos Suarez. I'm a member of the Department of Engineering at the Pontifical Catholic University of Peru. Today, I'll be presenting our paper called Using 5D Models and CBA for Planning the Foundations and Concrete Structure Stages of a Complex Building. Some background and context about this research is that there are three commonly adopted methodologies by building contractors in Peru. The first is last planar system. The second is building information modeling, which studies show that 1 out of 4 building projects in Peru use BIM. And the last is critical path method, which is mentioned as a contractual tool in the Peruvian government contracting laws. There are two main problems with the traditional methodologies presented. The first is the lack of synergy between planning and control methodology of the contractor, which is the CPM, and the lean construction philosophy. The second is the lack of integration within tools and procedures, which cause more effort needed to obtain outputs. So the first problem presented was the lack of synergy. One reason of this is the push control type that is caused by using CPM as a controlling tool. Also, there are some downsides of this controlling phase. The most important ones are not focusing in workflow and neglecting the production rates. The methodology proposed for this is using the location-based management system, which enables workflows and aim lean goals. About the lack of integration, which is the second problem, one reason is that BIM is mostly used for visualization, quantitative takeoff, and compatibilization in Peru. More effort and tools are needed to integrate the information of cost, duration, and quantities. This implies time and effort made by the engineers to obtain the outputs, and lots of fundamental details missed for the daily decision-making of the managers. The methodology proposed for this is the 5D BIM models. So we presented two main problems that are associated with the traditional methodologies used by the contractor. This approach is the CPM plus the 3D BIM models plus Lean, which involve three unconnected softwares. And the proposed methodology that we used in the research was the Flowlines plus 5D BIM models plus Lean, which had one software as database and process tool of cost, schedule, and 3D model. So to make a decision of which methodology will be preferred by the contractor, we use the CBA system to support the decision-making using comparisons among advantages of alternatives. And finally, the research shows the benefits of integrated scope, cost, and time solution for lean management compared to the traditional methods following and standardized decision-making. So, the case of study of the research involved planning the foundations and concrete structure stage of an office building. This had as constructed area 24,000 square meters. And to elaborate the research, we followed 5 steps. The first one was the framework of traditional methods. The second was gather scope, cost, and schedule information. The third was the elaboration of 3D and 5D modeling. Then in the step 4, we presented the model to the contractor. Discussions were made to determine the factors, criteria, attributes, and advantages of planning with the 5D model in comparison to the traditional 3D and 4D models associated with CPM. And then the input was gathered to elaborate the CBA. So the proposed methodology was the use of 5D models based in flowlines. To do this model, we follow 4 steps. The first one was the 3D modeling and the defining of locations. The second was the integration of cost, schedule, and scope information in one database. The third was the elaboration of flow lines. In this, we have several steps too. That was first the overview of the construction sequence in the project. The second was identifying the bottlenecks to ensure continuous flows. Here the red arrow shows the bottlenecks. Then we align the slope of the bottlenecks based on the production demanded by the internal milestones. The slope of the bottlenecks was identified as the backbone. The slope can be identified by the red arrows too. Then all the activities within the middle level locations, which are the remaining activities, were aligned guided by the specific backbone. Finally, some opportunities of improvement were discovered for the plant resources. We adjust the slope of the remaining activities and discovered that activities like rebar and soil filling needed an adjustment. So after the schedule with flow lines was done, we obtained an automated cost and resources report for all the details needed per time or per level of detailing cost. Then the methodologies were evaluated using CBA system. We had 3 evaluated alternatives. The first one was 3D models, CPM plus Lean. The second was 4D models plus CPM plus Lean. And the third was 5D models plus location-based management system plus Lean. The third alternative was the one that was proposed by the researchers to the contractor. And 1 and 2 was the traditional methodology used by them. In collaboration with the contractors, 8 factors were identified in the discussion, so I'm going to briefly mention them. The first one was plan an effective lean production system. The criterion was ensuring an effective lean production system is better. The factor 2 was synergy with earned value reports, and the criterion was less time spent with more possible details is better. The factor 3 was scheduling automation, which was less time spent is better. Factor number 4 was scheduling understanding. The criterion was better understanding from the engineers was better. Factor number 5 was learning process, and the criterion was less training hours needed was better. Factor number 6 was the quantitative takeoff and cost in time automation. The criterion was less time spent and more detailed capacity was better. Factor number 7 was scheduling understanding. The criterion was more relevant information that do not complicate the schedule analysis was better. And the final factor, which is factor number 8, was state contractual loss, and the criterion was easier determination and better visualization of the critical path is better. So as a result of the CBA analysis, we obtained that the alternative 3 was the preferred one. This was the alternative that was proposed to the contractor and involved 5D modeling, location-based management system, and Lean. Some key advantages that we could obtain of this analysis was that the alternative 3 ensured an effective lean production system, automated distribution of resources, cost, and quantities, automated calculation of resources and durations guided by the bottlenecks and milestones, and ensure more detailed capacity in the schedule. So, to sum up, in this research we found that there are 2 principal problems associated with the traditional methodologies and tools used by the contractor. The first problem is the lack of synergy, and the second is the lack of integration. This led to more working hours and less application of lean philosophy. We proposed a methodology to the contractor to avoid these problems. This was the use of 5D models plus location-based management system plus Lean, and this was implemented in parallel into the planning stage of the case of study. To elaborate the proposed methodology, we had to develop a flowline schedule. This was guided by the bottlenecks that were identified in the early stage of the scheduling. The bottlenecks identified was the ready-mix concrete pouring process and the soil filling process. After these bottlenecks were identified, we identified the slope of these bottlenecks guided by the internal milestones of the contractor. The slope of the bottlenecks were called the backbones of the schedule. Then we use a CBA analysis to compare 3 alternatives. The traditional methodologies were the alternatives 1 and 2, and the proposed methodology was the alternative 3. The alternative 3 was the preferred one and allowed us to plan an effective lean production system, report the baseline automatically with more detailed capacity, and allow us to have more automation in the resource and duration calculation, in the cost reports, histograms, and quantitative takeoff process. So, as a conclusion of the research, we found that the integrated scope, cost, and time is the preferred solution for lean management compared to the traditional methods. 5D plus location-based management system also allows us to have more automation, more essential details in visualization, and more reliable processes. Further research must be conducted to determine the automated results in construction phase, automated early warnings, and easier air value control. Thanks.